Microwaves are an electromagnetic radiation with wavelengths oscillating between 1 meter and 1 millimeter, along with frequencies ranging from 300 MHz to 300 GHz. They are energy bursts which are generated by various types of electronic transmitters. For example, in cell phones, there are used transmitter chips and antennas, while in microwave ovens, microwaves are produced by a special device called magnetron. This radiation is also produced naturally by planets, stars, galaxies, and nebulas. Microwaves are an integral part of our everyday life since they are used in many different ways here on Earth. But to find a true big-scale potential of microwaves, we would have to leave our planet, opting for further space advancement. We think that the future of space exploration is highly dependent on microwaves. Microwaves are very similar to radio waves, but they have much higher frequency. Furthermore, they travel only by line-of-sight paths and do not follow the contour of the Earth like radio waves do. Life without current knowledge in the uses of microwaves would be definitely much harder considering that they are used on so many surfaces. A huge revolution must be the use of microwaves in the communication system. They are prior to proper working of wireless LNA protocols like Bluetooth or Wi-Fi. Most other protocols have frequency of 2.4, 3.6 or 5 GHz. There are other devices using 2.4 GHz bands to communicate between each other, like security cameras, video senders, or baby monitors. The comfort of having an opportunity to communicate within seconds with the use of mobile phones is also credited to microwaves. The most common mobile phone network, GSM, uses microwaves with frequencies around 1.8 and 1.9 GHz transmitted from base station antennas that provide signal to connect every phone. Due to the fact of a shorter wavelength in comparison to radio waves, microwaves can be used through a relatively small directional antennas to watch a telecommunication transmission. Microwaves are the most common electromagnetic radiation used in radiolocation. Radar, as this technique is called, is based on waves bouncing off an object and returning to their receiver. With this, we can describe many information of the object, for instance, its distance, specific location, or velocity. Radar is commonly used in air traffic control, speed limit enforcement, or weather forecasting. It also finds its utility for short-range collision avoidance systems. Microwaves with frequency between about 1.2 GHz and 1.6 GHz and transmitted by satellites for global navigation satellite systems such as GPS, which provides our localization. There are 32 satellites at the altitude of about 20,000 kilometers. They transmit microwaves which are received by any device with a GPS receiver. Wherever you are on the planet, at least 4 satellites are transmitting microwaves to your GPS device. Navigation is based on trilateration, a mathematical method which can indicate your localization with a minimum of 3 satellites. Satellite equipped with a very precise atomic clock calculates its distance from GPS receiver based on how long did the wave travel. The calculated distance is a radius of a sphere, which middle point is a specific satellite. The point on Earth where all satellite spheres connect is your localization. Microwaves have a specific ability called radio frequency heating. Molecules, while being radiated by microwaves, have to constantly align to a changing electromagnetic field. Their motion produces energy in the form of heat, so that the heated product's temperature increases. This technique is commonly used in microwave ovens, pasteurization, sterilization, food preservation, but this means they can also transmit power over long distances. Leaning more towards space, we have to put emphasis on the importance of microwaves in astronomical studies. Using them, we can define the distance to certain astronomical objects and even observe the universe in millimeter and submillimeter wavelength ranges. But that's not all. With microwaves, we can observe a peculiar occurrence, the cosmic microwave background radiation. It's a radiation in the background of space which is considered to be a residue after the early stages of the universe's formation and relate to the Big Bang theory. In space, observed through a sensitive radio telescope, there is a slight visible background noise. Once very hot, now universe has cooled down after its expansion. Consequently, the radiation's wavelength has increased and its energy decreased. The cosmic background radiation phenomenon allows us to learn more about the creation of the universe. But even that is not all of the benefits that microwaves could give humanity in terms of astronomy. In 2001, Roger Shawyer proposed a model of a fuel-free thruster known as EM drive. Scientists to this day don't know the theory of M drive and why it's even working, because all of the recent theories have been inconsistent with known laws of physics, such as conservation of momentum, conservation of energy, and Newton's third law. M drive's main part is a microwave resonator shaped like a beveled cone, which closes electromagnetic radiation transmitted by a magnetron. Given that one basis of the constructor is wider than the other one, microwaves radiating to the wider bases should speed up and radiating to the narrower bases should slow down. As a result of the different wave travel speeds, they are to exert different radiation pressures on the opposite bases of the resonator, and in this way a non-zero thrust to move the ship is to be created. The invention is very controversial and Shawyer has been criticized many times. According to scientists doubting in M drive, waves traveling from one basis to another also hit the walls of the construction, so the force of electromagnetic waves should be equivalent to momentum should be zero. But it is not. This is a real struggle for theorists. M drive has been tested a few times already, and it turns out that it is working, even despite inconsistencies with laws of physics. We reckon that this kind of radio frequency thruster could be a huge revolution in few future decades, when it comes to astronomical studies and space exploration. M drive could use solar energy to transmit microwaves. Ergo, this technology would decrease weight of spaceships, satellites, etc. that are being launched into space because of the lack of fuel tanks. Moreover, it could be extremely beneficial in case of an economical factor, since it wouldn't require any financial resources for huge loads of rocket fuel. With less assets needed, humanity could increase the frequency and quantity of astronomical studies and explorations, with space conquest being the brightest and most prospective element in the future of mankind. Improving our technology is vital to any further breakthrough.